Okay, this is chapter 13, number 3. The question states a 200 kilogram object and a 500 kilogram object are separated by 0.400 meters. Part A. Find the net gravitational force exerted by these objects on a 50 kilogram object placed midway between them.
Okay, so for this problem we are given that m1 is equal to 200 kilograms, m2 is equal to 500 kilograms, and m3 is equal to 50 kilograms. Our radius is 0.40 over 2, which is equal to 0.20 because the object is directly in between the 0.4 meters, leaving it as 0.20 meters. And g is equal to 6.67 times 10 to negative 11 because it's the gravity constant. And we're finding the net gravitational force acting on the 50 kilogram object. So there's going to be a gravity force going this way towards the 500 and a weaker force going to the 200. So the overall net force is going to be going this way because the 500 has a greater mass than the 200. So we're going to be using our formula Fg equal to g m3 or multiplied by m3 multiplied by m2 minus m1 over r squared. So let's plug our values in. For g, we have 6.67 times 10 to the negative 11th times 50 kilograms times 500 kilograms minus 200 kilograms. And that's because it's the net force, so we use the difference between them. And then our radius is 0.2 squared. And then when you plug that into your calculator, it comes out to be 2.5 times 10 to the negative 5th newtons towards the 500 kilogram object. And it's towards the 500 kilogram object because in our diagram it's just going to have that net force going that way because this one weighs more. So that's the answer for part A.
Okay, so part B states at what position can the 50 kilogram object be placed so as to experience a net force of 0?
So what B is having us find is the distance between the 500 kilogram object and the 50 kilogram object when the gravitational force of the 200 and the 500 are equal. So yeah, when the 500 kilogram object's gravitational force is equal to the gravitational force of the 200 kilogram object. So we can solve for D by using our formula again. G, or the formula we're going to be using is Fg equals G m1 times m2 over r squared. And we're going to be using two of these. So G equals 50 kilograms times 200 kilograms over 0.4 minus d squared equal to G equals 50 kilograms times 500 kilograms over d squared. So now we can cancel some stuff out, the g's in the 50 kilograms, and that leaves us with 200 kilograms over 0.4 minus d squared equal to 500 kilograms over d squared. And then we can cross multiply this, leaving us with 200 kilograms d squared equal to 500 kilograms multiplied by 0.4 minus d squared. So what we're going to have to do is we're going to have to FOIL this out. So 0.4 minus d times 0.4 minus d, and that gives us that's going to give us 0.16 minus 8d plus d squared, and then we can rearrange that to d squared minus 8d plus 0.16. So 500 is going to be multiplied by that, giving us 500 d squared minus 400 d plus 80, and that's going to be equal to 200 d squared, and then you could subtract this 200 over, leaving us with 300 d squared minus 400 d plus 80 equals 0. And what do we have here? A quadratic formula. So we can use the quadratic, we have a quadratic equation, so we can use the quadratic formula, which is opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So let's plug our values in. We have the opposite of b being positive 400 plus or minus the square root of 400 squared, which would be 160,000, minus 4 times 300 times 80, all over 300 times 2, which would be 600, and this simplifies down to 400 plus or minus 253 over 600, giving us two answers, one being equal to 0.245 meters and the other equal to 1.088 meters. And so how do we decide which of these answers to use? Well, the correct answer is going to be 0.245. The answer is 0.245 because it's the lowest possible value that the gravitational force is 0. Net gravitational force is 0. This has been Chapter 13, Problem number 3. Thank you for watching.